All right. So very good evening, everyone. I welcome you once again for this day two of workshop using cryptography and steganography tools. I hope, yeah, you have enjoyed the day one session. So welcome the resource person, Mr. S. Prabhu. So over to you, sir. Please take over.
Yeah, thank you. Friends, yesterday we understood the basics, right? We understood the significance of why do we need computer network security, right? So before stepping into this, well, let's quickly run through what we have seen in simple explanation. So when we are accessing something from a device, right? So obviously this device, let's assume it's connected to the internet, okay? So now we know very well internet is a very connected network. So let's assume we are going to access a web server here. Okay. So let's assume that this is a server. Okay. So what happens? The data has to flow from this place to this place, right? So for example, if you are going to send the data, this data have to flow through the internet in order to reach the server. And obviously during its voyage, we don't know what happens to the data. And that's why instead of sending the data as a plain text, right? So whenever we say that it is a plain text, so we are not going to send the data as a plain text. Rather, we are going to send it as a ciphertext, right? So the data that is going to be transmitted over the internet is going to be ciphertext only. The reason is there are some bad guys here, right? So the bad guys we call as attackers. So we are calling these bad guys as attackers. So we want to protect our data. So let's say the password that we are going to send is 123, and we are obviously not going to send 123, right? Let's say this is going to be converted into M3, MZ, dollar, hash 2x, like this. Actually, this is the data that is being transmitted over the network. And this data, when the data that is created by the sender side, right? When the data that is created by the sender side, what happens? This data is actually 123. That is what it is actually created in the sender side. Now we are going to convert this plain text into this ciphertext, and this ciphertext is obviously going to flow through the network, and it's going to be received by the receiver. So here I'm calling this guy as the receiver, and the job of receiver is he has to do decryption at this end, right? So the decryption is done in the receiver side, and from the sender side, encryption is done, right? Now, what is cryptography? The collection of these two things, right? The encryption and decryption. These put together, we call it as cryptography. Okay. So we have a lot of cryptographic techniques, but basically any cryptography is classified into only two types. Okay. The two types of cryptographic technique that we are going to focus here are the symmetric cryptography, and the second one is asymmetric cryptography. The second one is asymmetric cryptography. Okay, so for convenience purpose, I'm just shortening it. Now we need to understand what is symmetric cryptography and what is asymmetric cryptography. This is also called as public key cryptography, and this is also called as private key cryptography. Okay, so today we will be dealing some tools about these things, but before that we need to establish a strong foundation of what is this. Okay, so this is what we have seen till yesterday. So the significance of having network security is undeniably an essential entity on the internet. Okay. So with this knowledge, let's step into the basic aspects. So what we have dealt yesterday, a quick recapture, just a 5-minute recapture. In day one session, we saw why do we need network security. We have a lot of devices. We understood what are all attacks. We also see we also have seen what's the scope of the attackers, right? There are multiple reasons for attacking, and simple attack we have seen using cookies, I mean capturing the data from the cookies. We also have dealt with spoofing, and we saw a demo using MK's webpage for email spoofing. Now, then we also have understood what is phishing, and we also have seen a real-time example for have I been pawned, right, for your data. So undeniably, security an essential element on the internet. Okay. So talking about cryptography, we have basically two types. One is symmetric, where the plain text is going to be converted into ciphertext, and ciphertext is going to be converted back to plain text. But the reason why it is symmetric, because the encryption algorithm and decryption algorithm are going to use the same keys. Okay, and this same key, if it is used, it's symmetric, and if they use a different key, okay, then it is asymmetric. No worries, anyway we are going to see some practical illustrations. At that time it will be clear for you. So let's focus on the first aspect, the symmetric. Okay, I'll give you some easy examples for this. we'll see some real-time examples also. So one of the symmetric examples or symmetric key cryptography is a Caesar cipher. Okay, so in the Caesar cipher, I'll tell you what is happening. We are going to name every alphabet with a number. Say, for example, A is numbered as 0, B is numbered as 1, C is numbered as 2, up to Z is numbered as 25. Obviously, because when it starts from 0, the alphabet, obviously the last alphabet Z will be having 25, right? So in this case, what a Caesar cipher is, we are going to just add the key value to the plain text, right? Say if our key value is 3, then the plain text character is added with 3, then we perform mod 26. Ignore this for now. I will give you an easy example. Say, I'm going to encrypt some text, Neso Academy, using Caesar cipher. Now, how I am going to convert this plain text Neso Academy using Caesar cipher? It's so simple. Just see what is the plain text, NESOACADEMY, right? Now, what we are going to do is we are going to take the first plain text character, because we don't want to send this plain text on the internet just like that, Neso Academy just like that. So we are preferring what encryption algorithm? The Caesar cipher, which is a symmetric encryption algorithm. So take the plain text position. Just take what is the position for n. N is actually 13, right? So 13 plus what is the key value we have taken? 3. So remember, for encryption, the key is 3. For decryption also, the key value is 3, right? So when we do this, we get 16. What is the character present in 16? We are performing mod 26. Basically, it's a division only. You will get remainder 16. So what is the ciphertext value we are getting for the plain text? 13. Actually, plain text is n, which means 13. What is the ciphertext we are getting? It's 16. What is the character present in 16? It's Q, right? So Q is the ciphertext for the plain text n. Likewise, for E, just guess. Looking at the slide, you do a calculation in your mind. So 4 plus 3, 7. 7 more 26, so obviously 7. So 7 is the ciphertext. What's the character equivalent for 7? It's H, right? So H is the character for the plain text E. Likewise, for S is V, for O is R, for A is D, for C is F, for A is D, and it goes on, right? So the last character Y, just see Y, Y, because if you see Y, the character, the position for Y is 24. So 24 plus 3 is 27. 27 mod 26. When you perform 27 mod 26, the remainder is going to be 1, right? So what is the character present in 1? That's the ciphertext, right? So B is the ciphertext. It's a left shift, a circular shift. So what I mean to say here is this is actually encryption. And if you want to perform decryption, that's the reverse. If you do +5, +3, do -3. So what is decryption actually? So in this case, we are sending Neso Academy, but we feel that sending Neso Academy is no more secured. So what we are sending? We are sending the ciphertext on the internet. Okay. See, remember guys, this is a cipher. Once upon a time when the internet and when people started using secure communication, they used it. This is all easily breakable. You see this is no more a secured one. Okay. If you write an algorithm using Caesar cipher, immediately it can be broken because the possible keys are limited. So what I mean to say is we are going to actually send this on the internet. And if somebody receives this information, they are not at all understanding what is the message it is, right? What message is that? No clue, right? But if we know that it's Caesar cipher, then they will be attempting with key 1, 2, 3 like that. Okay. So just see here, one more example I'll give you. How can we, we can break this. Okay. So I'll not focus more on this, but anyway, I will just give you one more example for Caesar cipher. Okay. This Caesar cipher with key is equal to 3, right? By default. But that is having a common, that is having a widespread drawback, because if for all the plain text characters, the key is unanimously 3, right? So what we are going to do here is we are going to focus on the next type of cipher, the monoalphabetic cipher, where randomly we are going to use. Ignore this portion because I'm not going to focus here. If the plain text is neso, you see, we know the position, right? For alphabet A, it's 0. For the alphabet Z, it is 25. N, which is actually what? The value for N, it is actually 13. When 13 plus 3, which is equal to 16, which was our earlier case, But in this case, what we are doing, randomly we are mapping, because in the previous case, the uniformity is there, right? For every plain text and ciphertext, 3 is the uniform value. If you identify one position, then cracking the other position is easy. So randomly you distribute this. So obviously you will get a ciphertext. But remember, when the character N is replaced as D, when sender is doing that, then receiver should also be kept informed about this, because when the decryption is done, he should know whenever he sees D, what is replaced with it is N, right? So that's how it works. And I'll also give you one more ciphering example, because our intention for today is to focus more on practical perspectives. But before going into the practicals, we should understand what is actually symmetric, right? In either case is what we have seen, the symmetric, right? The Caesar cipher and the monoalphabetic cipher, both are symmetric. But here in Playfair also, it is symmetric. Okay, I'll directly go to the example. I'm not going to the algorithm part. So we have 26 characters in English, right? So what is the nearest square matrix for 26? It can be 25 or 36, 5 cross 5 or 6 cross 6, right? So if we go with 25, obviously 26 characters cannot be accommodated, right? So what we are doing in simple terms, we have 26 alphabets. We want to store all 26 alphabets in a square matrix. If the matrix is 5 cross 5, we have 25 cells, 25. And if we go with 36, 6 cross 6, there are 36 cells and we have only 26 alphabets and we have 10 cells empty. But it's better to have only 25. So what we are going to do is we are going to take a key value. Here, let's say the key value that we are going to take is monarchy. Okay, this key is shared between the sender and the receiver. What I am telling you now is I'm explaining how we are creating ciphertext using Playfair technique. Okay. And Playfair is also a symmetric technique. So what we are doing, the sender is going to create a 5 cross 5 matrix. A secret key is chosen. Here the key is monarchy. And this is a symmetric encryption because the sender, he is using the key monarchy, and receiver is also going to use the same key monarchy for decryption. Let's see how encryption works. After filling the keywords, after filling the keyword monarchy, MONARCHY, then we have to fill the rest of the alphabets here. Okay, so let's start with the alphabet A. A is already there here, so we should not fill A. Now what's the next alphabet? B. B is not in the keyword, we are filling B. Coming to C, C is already there, right? So C is ignored. Coming to D, yes, D is filled. Likewise, we are filling the unused characters. Remember, I am always clubbing I and J together because there are 26 alphabets and I have only 25 cells. So somehow I need to put all alphabets in 25 cells. And that's why I am clubbing always I and J. And the rest of the alphabets are filled. Guys, I'm moving it fast. The reason is we don't want to go detailed into this, but I want to make you to understand what is symmetric. Okay, then we will go to the tools, then it will be easy for you to understand. So this is how a table is constructed. Now, how ciphertext is generated? There are some rules. I will directly go through it. First, diagrams are created, and these, let's see, attack. I'm going to encrypt the plain text attack. Let's say there is a terrorist, and this terrorist wants to send some confidential message to another terrorist, and these two terrorists are in different parts of the world, and at the same time they cannot communicate in a plain text. Say for example, kill someone, right, or loot this bank, or destroy this place, or attack this building, right? Because it is vulnerable, it's easily tracked. And obviously these guys, when they want to send some confidential information, they will not send the message as a plain text. Rather, they would be converting that plain text into ciphertext. And let's assume a terrorist is giving some instruction to another terrorist. I am recording this word terrorist just for an illustration. Please ignore it if it really hurts someone. So what I'm meaning here is a terrorist one is giving some instruction to terrorist two. Let's say attack. Now, how the terrorist one, the sender is going to communicate to terrorist two is not sending attack directly, but is going to generate a ciphertext. Let's say this is the keyword both are using, monarchy, sender and receiver. Now, what this guy is going to do is he needs to encrypt this plain text, right? Because encryption is going to convert the plain text into ciphertext. Now, he is going to break all these two characters. is going to break all this plain text into two characters each. Now A and T, right? So now he's going to generate this A and T is the plain text letters, and the equivalent plain text letters is going to be converted to its equivalent ciphertext letters. And since we are breaking it into two, we are calling it as diagrams. Let's say, where is A? Here is A. Where is T? Here is T, right? So the alphabet A and T, where they are, it's here and it's here, right? So we are just breaking the diagrams in order to make a row and column identity. Can you see here? A attack, AT, TACK. Likewise, if you say Neso Academy, you can also break that into two. Neso Academy. And if you are left with something, without any character, just use a filler character, yes. Then, for example, balloon, you break it like this. But if you see here, there are repeating letters. So what we are going to do is we are breaking that with a filler character X. Just insert X here and then make the diagram.
Sir, Prabhu sir, Prabhu sir. Students, I think there is some problem from this side. We'll get back to you shortly. Students, I think there is some problem from his side. Wi-Fi got disconnected. Just now he called me. Just 2 minutes. Hold on for 2 minutes. He'll be back.
Hey, sorry guys. Due to some glitch in the internet, Wi-Fi router got restarted. Can you hear me?
Students, yes, sir. Yes. Students, can you
Yeah.
hear us?
Yes, sir.
Okay.
Okay.
Thank you. Thank you.
Yes, sir.
Thank you. Thank you. Thank you.
Okay. We'll go to the topic now. Is my screen shared? No.
Okay.
Okay. Hey guys, sorry. It's for a small glitch from my side.
Happens.
Okay, now let's see how the symmetric encryption actually works. Okay, we know how to create the rules and all, right? So let's see how this encryption is actually done. Now, when we say this attack, the word attack, we know how to create diagrams. ATTACK. Now take A, take E. I mean, we are breaking that into individual diagrams. Now we will encrypt AT first. Where is A? Here it is. Where is T? Here it is. So just make a rectangle. Fine. How? Suppose if you are encrypting M and G, M is here, G is here. So your rectangle should be like this. Just follow my cursor. Your rectangle should be like this. Okay. So now what happens? A and T. Now see where and all it is there. A and T are in different row, different column. Right. Now how it is encrypted is A is encrypted as R and T is encrypted as S. Okay. Whatever it's adjacent to it at the end. Okay. So this is how it is encrypted. So the character present for AT is RS. I know things will be difficult at this stage. Let's see for TA. Where is T? Here is. Where is A? Here it is. So TA we are going to encrypt. So whatever is next to T, the opposite side is the ciphertext S. For A, it is R. So for T, it is S. For A, it is R. This is how it works. Let's see for CK. Where is C? Here it is. Let's see it for K. Where it is? I'm searching it for K. Here it is. Right? Okay. C and K. Let's see how it is encrypted. What is the opposite on the side? It's D. For K, what is the opposite? It's E, right? So C is encrypted as D and K is encrypted as E. So this is actually the ciphertext. So the plaintext attack is sent as RSSRDE. So when you send this word, no one can understand. But how this ciphertext is actually generated using two important information. One is the playfair technique, the 5x5 technique. And if anyone knows that it is playfair technique, but still they will not be able to identify this because we don't know what keyword we have used to generate this. Since we have used monarchy, we get this ciphertext. If we had used another keyword, say for example, computer, then we would be getting a different ciphertext. Let's see it for mask. How mask works? MOSQUE. M is here, O is here, right? So M and O are in the same cell. Remember, they in the same row. The previous case, they were in different row, different columns. So we found the adjacent. When they are in the same row, M should be replaced with O, O should be replaced with N. This is how the rule works for this technique, this playfair technique. For SQ, S is here, Q is here. So this is how it works, right? For UE, it's up and down. In the previous case, just see here.
Hello, Prabhu sir. Hello.
Replaced as O N
Sir,
T
sir,
S
actually
N A.
there was a pause in your voice for 10 seconds.
Oh, still.
No, now it is okay, sir. Now it is fine. Just 10 seconds.
Okay. Anyway, need not
Okay.
understand detailed because of this, because I wanted to emphasize that this is a symmetric encryption. Okay. So basically symmetric encryption, these are all outdated encryption. You see, nowadays, if you use playfair technique or any technique, they are vulnerable to attacks. Okay. Now, remember only one thing, whatever the way you encrypt, the same key you are using for both encryption and decryption, that is what symmetric is. Suppose if the receiver wants to decrypt it as mask, ON, MO is replaced as ON, and how ON is again brought back as MO. That's the same logic, right? ON, where it is ON. O is here, N is here. So M is replaced as O is replaced as N. They will do the reverse. So O is replaced as M, N is replaced as O, right? So the reverse of this. So what I mean to say is symmetric encryption uses same key. Now what we are doing now here and what we are going to do in our presentation and the demo is the public key crypto system. Let's say there are two parties, Bob and Alice. If Bob and Alice wants to do secure communication with symmetric encryption, either Bob or Alice will be conveying that, hey, this is the key that I'm going to use. So when I encrypt and send using this algorithm, just do the decryption using the same key. But that's symmetric. What we are talking now is asymmetric. Remember, this asymmetric is also called as public key crypto system. Okay, public key cryptography. So before they do the data communication, they have to generate the keys. So what actually needs is, let's say Bob is going to send some message to Alice. Okay. Remember, for understanding purpose only, we are using Bob and Alice. But in reality, a browser is going to communicate with a server. So browser is considered as Bob and server is considered as Alice. Okay. So this is just merely a representation. Now, when Bob wants to send some message to Alice, now the question is, in symmetric, if two people are involved, one key is enough, right? If two people are involved, one key is enough. If three people are involved, how many keys are involved? I'll just show it diagrammatically. You need to understand these things clearly. So I'll show it to you. In symmetric encryption, let's say there are two entities. Okay, let's say there are two guys, A and B. When A and B wants to communicate with each other, one key is enough, right? And because this is the key that is going to be shared between A and B. Let's say if A, B, C, three parties are involved. Between A and B, there is one key. Between A and C, we need the second key. Between B and C, we need the third key, right? So three keys are required. Are you right? Am I correct? So this is how it goes. But in public key, what happens if A and B are involved? A is going to generate two keys. A and B is also going to generate two set of keys, their own keys. Whatever A is going to generate, A will be generating his public key and his private key. So A is going to generate a pair of keys. It includes a public key and a private key. Likewise, B is also going to create two keys, a pair of keys, which is B's public key and which is B's private key. Okay, remember this is a mathematical concept. So if you do encryption with this key, and this key is required for decryption. In simple terms, let's say 10 and 2 are generated as the key pair by A. If someone encrypts with 10, it can be decrypted only with 2. You got my point? Likewise, if someone encrypts with this key, it can be decrypted with this key only. Okay, no other key in the world is possible for breaking it. So what I mean to say here is any party involved in public key crypto system, they definitely will have a pair of keys, their own pair of keys. Okay, unlike the previous technique, the symmetric, where the key is shared, right? If the attacker knows this key, the liability will be on both A and B. A will claim that I did not reveal, only B, you have revealed the key. And B will claim innocence by saying that I did not reveal the key, you revealed the key. But here there is no problem, because when A generates public key and private key, A will be sharing the public key with everyone. Hey, everyone take my public key. I don't mind. Anyone can have my public key. If you send any message by using my public key, no one can decrypt because the private key is with me only. Don't worry. No one can decrypt. This private key is kept confidential. Okay. This private key is actually kept confidentially. Okay. It will not be shared, not shared at all. So no sharing or not shared at all. Okay. So this is an important thing. So we'll come to the basics now, then it will be easy for you to understand. So when Bob wants to send any message to Alice, remember Bob is going to send some message to Alice. So what Bob needs to do is, first Bob should collect the Alice public key. Bob cannot use his own public key. Why? He's not going to encrypt and he's not going to decrypt. What's the use of him doing that? If he wants to send some message to Alice, Alice will be having two keys. What are the keys Alice will be having? Alice public key and Alice private key. Similarly, Bob will be having Bob's public key and Bob private key. The public keys are public. It can be shared. So when Alice creates her public key, she can share with everyone. Okay, she can share with everyone. See, first, what Bob is telling, I need Alice public key to send a message secretly to Alice. Right. Now, when he encrypts the message using Alice public key, which is her public key, no one in the world can decrypt it. Everyone will be receiving ciphertext, but no one can decrypt it except Alice, because the other key that can break this is the private key, which Alice alone knows that key. Right. So Alice says, when Alice wants to send some message to Bob, she needs to collect Bob's public key first. Okay. So anyway, don't worry about this. I will say only public keys are exchanged. Private keys are kept secret. So when I talk about the keys, I told you Alice will be having her own set of keys. Bob will be having his own set of keys. Public keys are kept, not kept confidential. They can be shared. Let's say if yellow color is representing the private key, Bob will never reveal his private key. Alice will never reveal her private key, but public keys are shared. Okay, so let's see one example, and that is why, say, when we access some websites, can you see here I am accessing a website, teams.microsoft.com, right? But remember, this browser is actually communicating with the Microsoft Teams server. Whatever communication is happening, it's going to the Microsoft Teams server, and then it is broadcasted to everyone, right, to every participant. Now when the communication is a confidential one, so from this browser, whatever the video data that is going out, right, it's encrypted. You are agreeing that, right? You are encrypted. All the text are encrypted. The words that I am speaking is an audio text. The screen that I am sharing is a video text. The text, something I am doing, everything is a confidential information. So what happens? This browser first collects the receiver's public key. Can you understand who is the receiver? The team Microsoft. This is actually the receiver. So this browser should know the receiver's public key. Let's see whether it is knowing the receiver's public key. Yes, can you see here? It knows the receiver's public key and this is the key. And what happens, it is going to use some public key algorithm, which is the RSA algorithm in this case, and it uses this key to generate the ciphertext. And when any data, see internet, on the internet, this entire data is going to flow. But except Microsoft Teams server, no one can decrypt because the key that can be used to decrypt this one is actually with Microsoft Teams only, right? So in that perspective, the confidentiality is achieved. So in simple terms, if you want to send some message to someone, collect the public key first. Encrypt the message using the receiver's public key, send it across the world. No one can decrypt except the receiver because the receiver only knows the public key, right? So let's see a demo now. So for this, I'm going to use the GNU PG package. So if you want to download it from the internet, you can download it using this website. I'll give you the details of these websites later, or you can also use this GNU PG, GPG, we will call it as GNU PG. And this is for Windows version. Once you click on this authentic site, okay, when you click on this authentic site, so it will ask you to download. It's an authentic site you can download. Otherwise, you feel that hey, someone has created a software, why don't we contribute $10 or $15? You can give that in euro or in US dollar. You can also give it as a one-time money, or you can also give monthly 100 rupees for appreciating their effort. Okay, but if you feel no, I cannot give, then click 0 and start downloading. Okay, so after you download this package, install all the applications. Okay, I'm not going to focus more on that because already we are running out of time. So what I'm going to do now is I've already installed this GPG package. Okay. So after installing this GPG package, it's simple, very basic installation only. Just download this application, install it. When it asks for what are all the components that you are going to install, select all the components. Select all the components to install. Next, 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 next. That's it. Installation will be successful. This GNU PG is actually a software suite. Say, for example, GPG for Windows. I am just showing it to you in the Wikipedia page. This GPG is actually a software suite. Okay, so this is a group of softwares under this package GPG for Windows. Okay, so most of the symmetric and public key encryption algorithms are actually incorporated in this single package. Okay, so this is I would say this is actually a software suite. Okay, suite means a group. So in that we have a tool called Cleopatra, Kleopatra. So what I mean, just download this package, install all the tools, then we are going to work on a single tool called Cleopatra. Just open this Cleopatra tool and you will find this Cleopatra tool will have the basic information about the settings. I'll show it to you. You see, this is actually the Cleopatra tool. So what we are going to do now is we are going to generate our own public key and our own private key. Okay, so to give us some time. So I have already created a key on March of March 19th. So I don't want to use this key. So I'll just delete this. So remember, I'm going to create my own pair of keys. Okay. So very simple. I'll just do one thing. So let's assume you're opening the key from the first. When you open a key, this very important point, if you are generating a key, it's a pair of key. Remember, that key will contain a public key and a private key. Because if you encrypt with public key, it should be decrypted with the private key, the corresponding private key. Any key will not work, right? So this combo is a key pair. So what I am doing is now I am going to create. See, remember, I am Prabhu. I am creating my own set of keys. So I am giving my name as the key name for identification purpose, and I am creating the key. Can you see here the key pair is now created? I am calling this as a key pair because it contains my public key and my private key. So what I will do, I will go to the desktop. I will create a folder. I will name it as Prabhu Keys. Understand the logic behind this. So I am just any name you can give. So for example purpose, I am just giving this name. So I've just created a folder Prabhu Keys, and I'm going to extract the public key and private key to this folder. Okay, so I have created a key pair from which tool? Cleopatra tool, and this Cleopatra is a part of GPG. Now right click on this key If you right click on this key, you can extract the public key and the private key. So first I will export the public key. And if you see here, this is the public key. Where I'm going to export is in the desktop. I have created a folder Prabhu keys and I will name it as Prabhu_public. For my reference, I'm just making it as public, and I will extract my private key, backup secret keys. Okay, so this is the secret key. I can also name it as private, okay, for understanding purpose. So this key pair what I created contains my public key and my private key. I have extracted my public key and my private key, right? So I should not give this private key to anyone. Remember, I should not give. Why? I can share this public key. Where and all I can share? I can send it in an email attachment. I can put it in my website. Say I have a website, for example. And if somebody wants to send some confidential information, I can display my public key on my website. Okay, you see, I have seen like long time back, I don't remember now, maybe 4 or 5 years back, I was about to contact an IIT Kharagpur professor, a professor in IIT Kharagpur. So when I wanted to reach him, I took his profile, okay, from the website, IIT Kharagpur website. Then I wanted to send him an email, so I was actually searching for his email ID, but I did not get that at that moment. Later, what that professor has mentioned in his profile is, if anyone wants to reach me out, just take my public key, encrypt the message, and paste it here. Then what happens when you take a plain text? Say, for example, you are asking professor, I want to collaborate with you on this project, for example. And if that's a confidential message, nobody should see. Let's say the professor is in Delhi, for example, and I am in Chennai. And the communication from Chennai to Delhi is somehow through the digital environment, right? So lot of routers are involved, but still nobody should see that information. In that case, I can collect that professor's public key, encrypt the message, and send it. I can blindly send it on the internet. I can even send it in the email also, right? In email also, because no one can decrypt except the professor, because he is holding his private key, right? Let's see how encryption and decryption works like this. Okay, so what I'm going to do is, I have just generated my public key and my private key. So what I will do, after you install the GNU PG packet, I told you to select all the components to install, right? Cleopatra, GPA, everything. So you just open this GPA tool. This is an editor actually. So just after opening this GPA tool, you will see the keys that are linked here. The key that you have created, 11/11/2022, right? Today that I have created. So let's see how encryption and decryption works. Let's say, Satish sir, who is the most studious person in this class? Can you hear me, guys? Okay, tell me who is the most dangerous person in this class. No one is dangerous? Okay, let me figure out some name from here. Okay, guys, can you confirm? Am I audible? Are you able to hear me?
Yes, sir. Yes, sir.
Yeah, you're able to hear. Okay, let me see some name here. Oh, okay, well, leave it. Let's not waste our time. Okay, what I'm gonna do now is, I'm going to show you how encryption and decryption works, right? So let's say the confidential message that I'm going to send is, let's say, Rajesh. Okay, so Rajesh, someone who is doing this. I am Prabhu, right? So I am going to give some confidential message to Rajesh. So I want to collect Rajesh's public key first, right? But in this case, since I have not collected Rajesh's public key, I don't have Rajesh's public key. So for demo purpose, what I am doing, I am assuming that I have collected Rajesh's public key. Okay. Now I am going to create my plain text. Rajesh, I am Prabhu. Please execute master plan 2 and drop the secret plan 1. So something I'm confidentially telling, right? Secret plan 1. Also transfer 2K to ABM. Something I'm giving. Okay. Kill Corona. So some message I am giving. And To encrypt this message, just click on the encrypt option. If you have imported Rajesh's public key, okay, so you will be seeing Rajesh's public key. So here I am assuming Prabhu's public key, okay, so for a demonstration purpose. So can you see here the message is now actually encrypted. So this is the ciphertext. This is actually the ciphertext. See what is the message that I have created? Something a readable text. But what I have done, I have converted the readable text into an unreadable text, which is the ciphertext in this example. Now, let's assume in this case, I have my own public key and private key installed in this tool, right? So when I click decrypt, my private key is already there here, and that's why it is able to decrypt it easily, right? So I'm clicking encrypt. I'm using Prabhu's public key. I'm clicking OK. Ciphertext is generated. I'm clicking decrypt, and I'm able to decrypt it, right? So what? Suppose you want to store some confidential message. Encrypt the message, okay, and save this message. And if somebody wants to loot your laptop and see what you have stored, and if they see this, definitely they will not be able to understand what it is. Even you can copy this message and send it as a Gmail text also, right? You can send it in Gmail also. So what I mean to say here is public keys are used for encryption, private keys are used for decryption. Now you may be asking how to download. See, I told you you can create keys and export like this. Assume this is Rajesh's public key. You ask Rajesh to send his public key in email. Then after collecting and downloading Rajesh's public key, go to your Cleopatra tool, click here. Instead of going to new key pair, this is how we created a new key, right? Here we are not going to create a new key. Rather, we are going to import a key. Click import from where? Let's assume this is Rajesh has sent. Okay. Click OK. Rajesh's public key will be there in your environment. So when you go to the GPA editor, when you click encrypt, when you click, where is that? When you click encrypt, I'll just open a notepad or any document, type something, then encrypt, you will be able to do that activity. I'll just show it to you. Give me a minute. I'll open GPA. You assume that you have imported Rajesh's public key. Okay, so you will see Rajesh's public key will be here when you import it into Cleopatra, because all these are software suite. Click clipboard, type the confidential message, click encrypt. While encrypting, click Rajesh's public key and click OK. You will get the ciphertext. No one can decrypt. Even you can't decrypt because the private key is known only to Rajesh. Since you created the message, you know what message you are going to send, but definitely no one in the world can see that message. So this is how public key and private key encryption works. Is that clear, guys? Can someone acknowledge, or you want me to explain one more time? Can someone respond? Is it clear?
Yes, sir.
Yeah, it's clear,
Yes,
right?
sir.
So what you can do now is, you guys, if you are really interested to work on these kind of small things, you can try downloading this. Download this GPG for Windows. If you are really very rich enough, you'd contribute in PayPal or whatsoever. So download this application, install the application, generate your public key and private key, share your public key with your friend, ask your friend, engage your friend to also create their own public and private key. Ask them, you just exchange your public keys, guys. You just exchange your public keys alone, never exchange your private keys. Okay. After creating public keys and private keys, after exchanging your public keys, encrypt your message by using their public key and copy that entire message. See, I forgot to tell you one more thing. See, when you open this GPA editor, when you create the message, say for example, you are creating a message here. Okay. So for the message is attack frequent building. And when you encrypt this message, when you use the receiver's public key, the ciphertext will be generated. Remember, don't copy like this. Copy like this. Can you see the difference? Don't copy like this. Otherwise, your encryption and decryption will not go in sync. You are copying the additional characters. See the last line. See the last line. You are copying the additional line. Instead, you copy this. You got it? Can you see the last line? I'm not copying. So if you copy like this space and all will be considered. Okay, so you might be not able to decrypt properly. The receiver will not be able to decrypt properly. So don't do like this. Rather do like this. So what you do? Just copy this. And how you can send this? Send it in email. You ask your friend to decrypt and tell me what you have created. Your friend will be definitely able to do it because while encrypting, they have used their public key, right? So you have used your friend's public key for encryption. So obviously your friend will be able to decrypt it because that decryption works because this message is actually encrypted with the public key, and this public key and the receiver's private key are a common key pair are generated. Let's say 10 and 20. If you encrypt with 10, it can be decrypted with 20 only. If you try 30 or 40 or 50, it won't work because that's how the key is all about. Okay. So this is how the public key and private key crypto system works. And what demonstration we have seen today is the Cleopatra tool and the GPA editor, GNU-PG or GNU-PA personal assistant or privacy assistant, you can call it here, because this is helping you to do encryption and decryption. Okay, so I'm not going to touch upon the keyring aspects and all. So this is how the logic goes. So when you get some time, guys, you see, I'm showing you a website, a securitysite.com. See, a lot of encryption algorithms are there. Even Cisco has their own set of protocols. Even Cisco has proprietary protocols, and that's why Cisco has a separate tab is opened for him. Actually, this is not Cisco site. This is someone has created this, and he has used the Cisco routing. All these are Cisco related products, right? If you know, if you want to know what's the Cisco, they are the leaders in the networking. See, we might be knowing Google, we might be knowing Microsoft, we might be knowing Facebook, everything, right? Because we are experiencing all these devices and devices. But these Cisco are dominating in the networking field. They are Cisco is actually a software company that works on the networking aspects, server aspects, and all the networking related areas. Okay, so say even Microsoft uses Cisco products, because if Microsoft needs routers and switches, Cisco are the leaders. If you want to know more about them, you can also search. So what I would suggest is just click on the ciphering technique. After you click the cipher, you will find a lot of ciphering technique, and you can also choose one cipher which we have seen now. What is that? The Caesar cipher, correct? So click on the Caesar cipher. You will get the Caesar cipher example, and you can learn about the Caesar cipher. You see how Caesar cipher works. A is replaced as D, 3 shift, right? 3 shift. B is replaced as E, and that's how when you get X, just rotate it, A, B, C. So this is how the plaintext ciphertext combo works. So this is what exactly we call as a Caesar cipher with the key 3, right? So we have a lot of ciphering techniques. You go through one by one. Even we have that playfair technique. Where is that? I'll just show you. We saw just playfair technique, right? I've just shown you on demo. So you can click on this, you give the keyword also. You can also check how it works, how the keywords are created, a 5x5 matrix are created. For example, how attacks works, A, T, T, A, C, K, the same example I told you. A and T are here, right? So make a rectangle here. So A is replaced as E, T is replaced as M. So the plain text AT is replaced as ME. So this is how it works, right? You just go through these things. If you want rules also, you can see the rules. Even coding is attached. So this is a very popular site in terms of learning security. Okay. And also, if you want to know about various encryption schemes, click on Encrypt. RSA is a very good encryption scheme, right? Elliptic curve cryptography is there. So Al-Gamal crypto system is there, on various public key cryptographic techniques are mentioned, but this will be advanced. If you go through this now, it will be advanced. And the tool, what I have shown, I'll just show it to you, Cleopatra tool, right? In the Cleopatra tool for generating the public key and private key, just see, suppose if I want to create a new key pair, I'm clicking on this, just click on this advanced setting, you will see some advanced algorithms, the RSA algorithm, the digital signature algorithms, the elliptic curve digital signature algorithm. Okay, so some algorithms, all these terms will be new for you, I'm pretty sure. But what I would suggest is everything is new unless you explore it, right? So you should not find anything as a black spot or a blind spot. So what I would suggest you start exploring. You can also start from here, starting with the home page, what and all they have given. I know if you go through this blockchain, it will be difficult for you to understand at that moment. Cryptocurrency, yes, of course, difficult. Diffie-Hellman, what is this Diffie? What is this Hellman? What is discrete logarithms? Dislogs, they have mentioned it as, right? So you will be actually feeling everything will be difficult at the initial stage. Say if you want to have some simulators also, they have used some Cisco simulators. You can try all these things. But what I would suggest is just explore things, If you find something is new, you start focusing on what is this AES. You see, AES is a very popular.
Prabhu sir, can you hear me?
Yeah, I can hear you.
Sir, sorry for the interruption, sir. There is no power since 1 hour, sir. My laptop is running out of charge right now.
Okay, no problem.
I just
We
wanted
are
to give some
going to
information
complete.
to
I'll complete it.
yes,
No
sir.
worry.
Just I wanted to give some information to the students.
No problem. No problem.
Students,
Thanks
once
for the
the session
insight.
is thank you, sir. Students, once the session is over, just log out the session, and then you'll be receiving the day 2 feedback link as well. So try to fill that feedback link before today ends. Thank you. Thank you, sir.
Yeah.
Proceed.
So yeah, thank you. So try exploring all these things. So now what I'm going to explore now is an introduction to tomorrow's session, steganography. What is steganography? I will explain you. But for now, what I'm going to do is I'm just going to say how information is encrypted here. Okay. If you see these two images, and if I ask you a question, are they same? But you will, with the naked eyes, you would be saying, obviously, yes, they are green colored images, right? But honestly, they are not. And also, I will explain you tomorrow. This is an image. This is an image where there are no hidden text, right? Don't assume hidden text means we are writing something. It's not like that we do in paper and pen, using paper and pen. Here all are binary codes, right? If you take a pixel, that pixel will have some values anyway. Don't worry about that now. Tomorrow I'll be explaining you all these things. Now this image looks the same, this image also looks the same, but here there are no hidden information, but here there are hidden information. How information is hidden inside this image, that is what we are going to see tomorrow, this steganography. In cryptography, what we did, the plain text is actually converted into ciphertext, right? So when you get some ciphertext, there is some insight that some confidential message is converted, but here there is no clue. If you send this image to someone, they don't even know whether some information is hidden there or not. Okay, so for that, what we are going to do is we are going to use an open stego tool for doing this, hiding this image activity. Okay, so what we will do tomorrow, we will do LSB steganography, and we will compare how steganography and cryptography differs in their operation. Okay, I hope the session is informative, and if you have, I have 2 more minutes to sign off. If you guys have any doubts, you can ask me. Or if you feel the session is really good or you learned something new, you can share with me. 1 or 2 feedback would be fine, because I will take it as an overall feedback. If you had really enjoyed the session, say simply yes or no, unmuting.
Yes, sir. Really enjoyed, sir.
Okay. Thank you, guys. So if you have any doubts, so tomorrow after seeing the LSB steganography, we will have a Q&A session where we will interact more about some general things, what's happening in the industry. Even I am not 100% sure what's happening in the industry every day. New fields are emerging. So we will see some different things and techniques and tips and tricks for cracking interviews, and how to equip yourself, what industry expects, and how you can make yourself equipped and enriched with the skill set. And if you feel I don't like programming, what are all the other opportunities and possibilities for you to be in the software market or in the IT market? If you feel you are good in programming, you are good in Python, C++, Java, and what are all the job opportunities? No, I don't want programming at all. I want to somewhere survive, but still I want to earn more. I want to become an entrepreneur. Of course, we will see those aspects tomorrow elaborately. So I think we have 1 more minute left. So that's for the day, and we will meet tomorrow. Thank you guys for your patient listening. So I'm signing off. Take care. Bye-bye.
Thank you, sir.
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 Thank you.